Oh, where is it? I can't find it anywhere. Oh, hello there, my packaging pals. It's me, Professor Packaging. Now, I've ordered a digital tablet, and I can't find it anywhere. It's got to be in here somewhere. Packaging, more packaging, more packaging. Aha! Found it! Now, this may be an extreme case of over-packaging, and they wouldn't necessarily use a huge box to package a small digital tablet. But over-packaging does happen, and that's what got thinking about my theory, E equals MP squared. Allow me to explain. Companies are keen to protect expensive devices, such as tablets, laptops, smartphones, and they use a lot of packaging in an attempt to prevent damage. But they use too much. I'll recycle that later. And it's this over-packaging that got me thinking about my packaging theory. E equals MP squared. Now, the E stands for environment, and the MP stands for maximum protection. And it's squared, so it has two meanings. It also means minimum packaging. Now, over-packaging is not good for the E, and certainly not any good for the MPs. And I'm going to show you how. Okay, so we have 4 key problems with over-packaging. Problem number 1 is the excessive use of packaging material. Now, in some cases, we've seen 50% more packaging material used than what's absolutely necessary. Now, problem number 2, I need to go into the warehouse and change my glasses. See you there. Okay, so I have my protective equipment on, which is very, very important. Now, key problem number 2 is the impact of over-packaging in transportation. Now, it doesn't take Einstein to work this one out, but the bigger the box, the fewer that can be carried by a forklift truck, which has to make more journeys back and forth during loading. This has an effect further down the supply chain where HGVs are unloading. Thank you, John. And what about the use of extra storage space for distribution centers and warehouses? They need heating and lighting, which uses up more energy. There's also transportation space. Now, if a package takes up too much space, then fewer products can be transported by truck. The same can be said for a plane, train, or ships, which means more transportation mileage is required, which could lead to high levels of carbon emissions. Okay, for key problem number 3 is the end of packaging life. Where excessive packaging material is being handled, it fills up recycling bins and vehicles, once again adding to the processing and transportation and those carbon emissions. And finally, key problem number 4 is not so much about the environment, but still very important, customer frustration. Now, over-packaging can annoy customers, which means this could affect brand loyalty and purchasing decisions. Now, how do we solve these issues? Well, let's see E equals MP squared in action. To the lab. Okay, so in my humble opinion, Sealed Air are experts in creating protective packaging solutions and are helping customers solve those 4 key problems. Now, one way of doing this is by using Corvu packaging solutions. Now, Corvu uses retention packaging, which holds a tablet in place, protecting it against vibrations and shocks. The cardboard is FSC certified and made up of at least 50% recycled content. You can also recycle with the film attached, where local curbside services are available. In one case, we saw a customer switch to Corvu packaging solutions, and they reduced carbon emissions associated with the transportation of the primary packaging by up to 52%, with an 8% reduction in carbon emissions associated with the transportation of the packaged good. Now, with Corvu minimizing packaging, they were able to load more boxes per pallet, meaning more products were being shipped, reducing vehicle usage and mileage. So that's how E equals MP squared applies to supply chain sustainability. Now, if you'd like to reduce over-packaging whilst maximizing protection, then contact my friends at Sealed Air. They really are experts at this. Well, my packaging pals, Thank you for watching, and until next time.